Okay. Um, about the reading packet. In case you haven't caught on, I always put something from the reading packet on the exams. They're supposed to help you with stuff that the book maybe doesn't do very well. Um, the reading packet is usually for context or for trivia because I think some of this will help you on the exam. But I don't know, it's not the test itself, so maybe it's not explicitly testable unless it's like a little concept. I do my best to point out which parts of the reading packet are most important. And whenever I go over these study goals, I usually just make some commentary on the articles, assuming you've read them. So here's my commentary on the articles for the reading packet in 4.3. In number 39, oh my God, cavemen caused a lot of extinctions. Technically, they weren't cavemen, but you know what I mean. Early humans caused a lot of extinction. In the Pleistocene, humans were traveling right along the edge of the American continent. Most of the American continent was covered by ice unless it was the coastline. So there was very little range to many mammal species. And as humans hunted that area, we basically hunted to extinction a lot of animals that had very limited populations due to the Ice Age. Kind of a fascinating thought. We think of, primitive man as being either less technologically capable or somehow super jiving with nature, and not so. This is the theory of the Pleistocene overkill, that we killed too much stuff. For number 40, remember that you had some notes in an earlier unit about how agriculture was tied to early population growth. For number 41, I guess it's kind of cool to know where agriculture was born, and it's important to remember that it was born in multiple places. Agriculture did not arise once. A lot of countries will say, we are the home of agriculture. That means that they are one of the places where agriculture arose. I'd like to talk about number 42 when we talk about soils. I believe that'll be tomorrow, and I need a student to please remember to ask me about number 42. We will talk about how ancient farmers addressed soil problems when we talk more about soil. Mayan agriculture, kind of an important historical detail. Aswan Dam, I really think that this is a place you should underline and remember. The Aswan Dam is on the Nile, and kind of fascinating. It was one of the first international arguments over water. I can't remember which country's on which side, but one country, I'm bad at geography, sorry. One country dams a river that would historically take water and sediment to farmers in the other country. And now that the sediment is trapped by the dam and the water is controlled by one country, that ruined the farmland of another country, and they had a big conflict. That's probably worth knowing. I believe that has been on a previous AP test. It's called the Aswan Dam, and it's on the Nile River. That's for number 44. You have that all in the notes. Number 45 is just kind of the trivia that they would like you to know. How much is grain? How much is used for growing stuff to feed to animals? Number 47, the social stuff is debatable. We don't need to discuss those implications, I think, here. But the environmental downsides to the Green Revolution are important. We used a lot more water and a lot more chemicals that had a lot more water pollution implications. And it's important to remember that agricultural output roughly tripled in the Green Revolution, but agricultural inputs more than tripled. That's an important fact. Remember, the Green Revolution is not Priuses and bamboo floors. Number 48, remember that there's plenty of food. The secret is, how do you get it to people who are hungry? The distribution lecture that we had earlier in this class. Number 49, this is going to keep coming up. The whole trophic pyramid inefficiency thing. We use a whole bunch of resources to grow cattle. To grow plants. And then we feed them to cattle. Now remember that when poor people get a little bit of money, the first thing they do is eat better. So as quality of life is rising globally, there's more and more and more people who need that cattle. But that means that for every calorie of meat, they're like multiplying the need of agriculture 10 times more. In other words, like for a calorie of meat that a poor person can now afford, there is now 10 times more agriculture required to feed that. So as quality of life grows, meat consumption grows, but that means that agricultural production has to grow a lot faster because a lot of agriculture is required to make that little bit of meat. It's not fair for me to say, yo, poor guy, you're not allowed to have meat. If somebody can afford it, we have made an open economy globally. But I think we may have kind of blown it by getting so excited about meat production. I don't think we can make enough meat for everybody. Contrary to what it says in number 48, there is enough food for everyone. There may not be enough food to make enough meat for everyone. Remember that trophic pyramid rule of 10% thing. So number 52 is kind of an important little thing for you to remember. Just remember when we get to the water unit that the number one source of water pollution in terms of chemical pollution is agriculture. And actually, even sediment pollution comes primarily from agriculture. So there you go. The number one source of water pollution is agriculture. That's kind of a crazy thought. For number 53, of all my food rules, this is the one that I would probably recommend the most. There's a bunch of benefits to eating close to home. If you don't have these, get ready to write. For one thing, if your food comes from close to home, it has a way smaller transportation cost. And we got to talk about transportation costs for a minute. The average American plate travels 1,250 miles. That means if you average all those ingredients, it's 1,250 miles. That's a lot of gasoline to move our food. And then if you add the gasoline of producing that food, and then you add the gasoline of refrigerating that food, of processing that food, the production, processing, refrigeration, our diet has a huge energy footprint. For most Americans, if you're an average American, you make as much global warming with your diet as you do with your car, with your transportation. Point being that by eating local, you can cut out much of the energy used by your diet because your food is closer to home, so it has less transportation cost. That's one thing. You have a smaller carbon footprint because the food doesn't have to travel as much. By the way, that in itself is a big deal for the College Board, and I'm not sure that'll come up a lot in our class, so don't forget that one. Number 2, having local food means you have control over those rules because you can vote. So locally, you might know what your water issues are. If my strawberries come from Ecuador, I don't really know what Ecuador's water issues are. So you have more local control. That gives you some political power, democracy works sometimes. You can keep your economy local. If I pay my farmer, then he's going to buy fish from me someday, and I kind of get some benefits from that money being in my neighborhood. If I pay my farmer, he's going to help pay my dentist so that my dentist still has a job so that my dentist can fix my teeth. We keep that money local. When I buy strawberries from Ecuador, that's, you know, helping a dentist in Ecuador. That farmer now takes my money and uses it in their economy. And so localizing keeps your economy tight. You're not leaking money to other economies. And generally speaking, small economies considered a good idea. It's also important to remember that if it doesn't have to travel very far, you get to eat it sooner, so it's picked fresher, and that means it's picked riper, and that means it tastes better. You can replay that. A lot of benefits to a local diet. Always nice to know your farmer too. There's some people who say like local diet, something about allergies. I think that's hocus pocus, but anyway. And number 54, I should have put a star on that. I messed up. So you should go back and look at number 54. I need you to see how much energy goes into the cost of food production. I'm going to try to change this slide so I can warn you at some point during class time to make sure that you watch this part. We're at about, I don't know, I'm guessing 10 minutes or so into this video. Tell your friends. Number 54 should have had a star. You do need to know how much energy goes into food production. Look at how much is in making the food, growing the food, processing the food, transporting the food. I need you to notice how much energy goes into that. The top 10 reasons to buy organic, I guess, might be debatable, and everybody keeps talking about the food being healthier for the person, but that's wrong. Even this paper, I think, says that, and even that would be wrong. Number 56 gets a lot of stars, and this will come up in the future units as well. We grow a lot of food because you can take the sugars and the carbohydrates out of that, and you can do fancy chemistry to take those little carbon bonds and make them into longer carbon chains that we can use in our cars. It's called biofuel. It's when you grow food and you do some chemistry to make long carbon chains, you know, that we can put into gasoline or put into diesel engines. That's actually a really good idea in carbon terms, because you're taking CO2 from the air to grow the plant, and when the plant is used, you're basically putting that carbon back, and that's all current carbon. As opposed to fossil fuels, where the carbon comes from under the ground and that has not been in the air, and then we take all those rocks and we put that up into the atmosphere. Fossil fuels are like a volcano taking lithospheric carbon out and putting it into play again. Great benefit for biofuels is it's all current carbon. That CO2 would have gone back to the air anyway. Somebody would have breathed after they digested that sugar, or that plant would have decomposed and that carbon would have gone back. So the nice thing about growing our fuels is we're taking current carbon, using the benefit of breaking those carbon bonds and putting it back into the air. Biofuel is a pretty great idea. Biofuel, good. Remember this part. Except ag biofuel, bad. You see, there's a lot of plant material that we could be using for energy sources, like grass, like lumber waste, like agricultural waste. But there are so many energy inputs to growing food. Go back to study goal number 54. There are so many energy inputs to growing food that by the time you've made agricultural biofuels, you've already used a bunch of fossil fuels. So now you get to replace the fossil fuels, but you use more energy to make the biofuels than you got out of using the biofuels. As a good rule of thumb, we're using 1.2 barrels of fossil fuel energy to make 1 barrel of agricultural biofuel. So it doesn't make sense. You're not actually saving anything. Biofuels are a rad idea if we can get natural or scrap biofuel. Ag biofuels are a horrible idea because their carbon cost is greater than their carbon savings. Ask me more about that one if you have any questions, but I am done talking about the reader.